Today we're going to be looking at an algebra topic. We're going to look at multiplying any two polynomials together. So we're going to start with multiplying monomials. So remember, monomials have one term. There's no plus or minus signs in there. So we can see an example right here of multiplication of two monomials. So the rule is we're going to multiply the coefficients. So those would be the numbers in front of each monomial. So for number 1, the coefficients are -7 and +3. So we would multiply those together. I'm going to go ahead and write this out in a separate step. And then we're going to multiply the exponents using the rules for exponents. And it also mentions commutative and associative laws. So we're going to use these to reorder. So remember our rule for multiplying exponents, we're going to keep the base, we're going to add the exponents. So what I'm going to do is I'm going to use my commutative and associative laws to regroup. I'm going to put the A's together. I'm going to put the B's together, and I'm going to put the C's together. Now, quite often we do not write this step that I'm writing out, but this should be kind of your mental grouping if you don't write it down. Now remember, anything that doesn't have an exponent, it is understood to be a 1. So I start by multiplying those coefficients. That's -21. Then for the A's, I keep the base and add the exponent. Same thing for the B's. Same thing for the C's. Okay, so I end up with -21, a to the 3rd, b squared, c to the 8th. So let's do the same thing for number 2 where we rewrite. So I'm going to pull out those coefficients. They go first. Then I'm going to put my a's together. I have a cubed and a to the 4th. I have b to the 5th and b. And then I have c times c. So anything that doesn't show an exponent, remember that's a 1. I multiply the coefficients, so -48. For multiplying exponents, I keep the base and I add the exponents. So I get a to the 7th, b to the 6th, and c squared. So a lot of times we don't show this step. We may do this mentally. So for number 3, I just may think, okay, 2 times 4, that's 8. And then I look at my x's and I say, okay, they both have an x. I'm going to add those exponents, and I'm going to get 8x to the 8th. And so let's try that again on number 4. Let me go ahead and use a highlighter to kind of help us out here. So we're going to start with the coefficients. -5 times -2, that gives us +10. Then I move to my x's. I have x to the 6th, and I have x squared. So I keep the x. And I add the exponents, and then I move to the y's. I've got y to the 7th, I've got y squared. I keep that base of y, and I add the exponents. So notice when I'm done, everything is a product, everything is multiplied together. All right, so our last one, we're going to go -9 times 3, that'll be -27. Notice my a's, a to the 1st, a squared. If I add those exponents, I get a to the 3rd. The b's are both b to the 1st, so b times b will be b squared. The c's, I have c to the 4th and c to the 1st, so that's going to make c to the 5th. All right, so that's a monomial times a monomial. Next, we're going to look at a monomial in the front and then something with 2 or more terms going next to it. So what we use for this is what we call the distributive property. And I can't quite fit all that in there. The distributive property is used to multiply polynomials other than monomials. So I'm going to take this whole monomial here and I'm going to distribute it. So what that means is I'm going to multiply it to each of these separately. So this first time I'm going to write out a middle step. I'm going to take the 2a squared and I'm going to multiply it to the 4a cubed. Then I keep that minus sign in the middle. Then I'm going to multiply 2a squared again to 5a to the 4th. So we can see that this outside monomial gets multiplied to both of the terms on the inside. So this goes right back to what we were doing up here. So 2 times 4 is 8. Then if I add the exponents, that's a to the 5th. Minus 2 times 5 is 10. and that would be a to the 6th. Now notice these are not similar terms. I can't add an a to the 5th and an a to the 6th together, so I'm done. All right, so let's try the same thing with number 2. Now this one I'm going to try not to do the middle step. So I'm going to start with 9a times 4a cubed. So 9 times 4 is 36. For the a's, my exponents are 1 and 3, so they add to make 4. Then I keep that minus sign. 9 times 8 is 72. Notice I have an a here, but no a's there. So that a just comes down. Okay, so what I really did, if I do show my middle step, sometimes it's useful to show it. Right here, we multiply the 9 and the 8, and then that a just kind of tags along. Now, quite often, we're only distributing a number, so that's a little bit easier. So 6 times 4 is 24. Keep the minus. 6 times 2 is 12, and then we're going to keep that x on the end. All right, so for number 4, we're distributing a 4a. So we're going to multiply, notice this is a trinomial. We're going to multiply it across 3 times, so we'll have 3 terms when we're done. So 4 times negative 3 is negative 12. If I add my exponents, 1 plus 2 is 3. So negative 12a to the 3rd. I'm going to keep that minus sign. 4 times 7 is 28. A times a is a squared. Then keep the minus sign. 4a times 1 is just going to be 4a. Don't have any similar terms, so when I get to here, I'm done. And then my last one, I'm distributing the 5xy. So once again, I've got a trinomial. This is going to distribute 3 times. So 5 times 7 is negative 35. 5 times negative 7. For my x's, my exponents are 1 and 2. So that adds to give me a 3. Same on the y's, 1 and 2. That adds to give me a 3. So that's all your first term. Then I'm going to go keep my plus sign and start over again. So 5 times 6 is 30. For the x's, 1 plus 4 is 5, so x to the 5th. Y times y gives me y squared. Then my last one, I keep the plus. 5 times 2 is 10. X times x is x squared. Then I have a y times no other y's, so I just bring that y down. Now this looks kind of messy, but notice that your exponents are not identical all the way across, so none of those are similar terms. They cannot be combined.